Hello, so I'm going to show how to do the spin4 command and what it means for programming in terms of reliability and repeatability. So this is being written in C++ in RobotMesh for the VEX v5. Specifically, I'm using this as an instructional tool for my competition teams. So this right here is just kind of pulled out of what would be your autonomous section. And C++, those two backslash, it's just a note, so people can see that throughout the video. I've already defined my motors and my motor setup. I did that right at the get-go. And I've got a left motor and a right motor on my dummy bot. It's just a very simple robot that I have. Obviously, the setup for your robot might be different if you have 4 drive motors, but in this case, I've just got the 2. Now, the spin4 command is going to spin based on the encoders in the motor, rather than using the system sleep option for a pause in the code reading. And the reason I like this better, in theory, is if you're just relying on time, a lot of things affect how the motor operates. There could be friction, there could be slightly lower voltage coming from the battery, or one battery versus another battery. However, if we're just counting on the wheel rotations, we know that it's going to complete that distance. There might be some slipping or skidding or something like that could happen. This isn't 100% foolproof. But if I know the wheel is going to spin 5 times every time by my program, that is more reliable than saying it's going to be on for 5 seconds. Sort of like if I told you to run for 5 seconds as fast as you can. Depending on the day, you might do a little different. Depending on how you're feeling that day, you could be doing really well, or you could be doing less well if you're tired, low battery, for example. But if I told you to run 100 feet, you would always run 100 feet, theoretically. So that's what this is kind of getting us towards. So in this line, there's 2 lines, and there's basically 2 different ways that I'm going to recommend that we do this, and this is for driving mostly specific. So I've got my motor first, dot spin4, and there's a bunch of different spin4 operations. The specific one I'm using, I'll just explain each section. The first section is, there's the full details, is how many revolutions that I want this to spin for. And it knows that I'm asking it for revolutions because of the text that I have right here, VEX rotationUnits rev. So you could have that in degrees, but I like revolutions because I don't want to put 1,000 digits there, like thousandths. Yeah, I don't want to have to put like 3,000. I want to just put like 12. So 12 revolutions is a pretty good distance for those wheels. So that is 12 revolutions. And then here I would put the speed, and I had that, there's a, oops, I'm going to put a numeric value in for speed. I had it written as text for something I'll explain in a later video. So I'm going to say 100%, and the reason it knows it's percent is there's the 100, and then right after it right here is the unit for it. So instead of percent, I could have degrees per second, but I just have it as percent. As far as I know, it doesn't make a big difference what unit you choose, as long as the numeric value makes sense. So I like this because I can say like 80 for 80%. I can slow it down by a quarter, make it 75%. It's just easy for me to think in my head. 100 is full speed, and then negative 100 is all the way is full speed backwards. So again, the number of degrees, or sorry, units that I'm using, which is revolutions, at this power, and that's the numerical value for this unit, which in my case I'm using percent, or PCT as it's abbreviated here. So at the very end of this statement, though, it says comma false. Now the reason it says comma false is it's a Boolean, meaning a true false set of system for do I keep reading or do I wait until I'm done doing the thing you just asked me to do. If you say false, it will immediately go to the next line. Now, if you say true, it will wait to keep going. This is important if I have 4 motors that I need running. So motor left, maybe you have a front left, a back left, a front right, and a back right. I want it to read all of those lines but I need it to stop before it goes on. Otherwise, it'll just fly through the whole thing, and it'll just be done before it's done anything. Because it's just going to read all the lines, and it'll just process too fast. So we want it to pause in chunks. So the way I'm having my team set up right now is they'll put all their motors, all the ones before the last one will say false for that Boolean, and then the last one will say true for that Boolean. So it's going to do all of those things, but then it's going to pause here and wait for that one to be done, just so that now I can do my next operation or movement or motion right after it, and it's not going to sort of fly through and skip sections, so to speak. So this one says true. So if I was running this, like in my example video I did the other day, and I can link it in a YouTube video, it is doing chunks at a time. It's doing like 2 of them, waiting for them to finish, then going to the next 2, waiting for them to finish, then going to the next 2. If all of these said false, it would basically read the whole program, and the program would end because it had no reason to stop reading, and it just would read to the end of the program. So that's a quick explanation for spin 4 operation in C++ on RobotMesh for VEX v5.